Hello, friends. A very happy new year and a safe year ahead. Let's talk about the implementation of support vector regression. We have already seen in the previous video the modeling of support vector regressor. We even in short we call it as SVR. Today we'll talk about its implementation using Python. Now, we'll directly start with an example. So what we are doing here, we have taken example one. So here we are going to predict the experience of a person based on his or her age, right? So what is our problem analysis? In this data, we have one independent variable because we know we are going to take the correlation between dependent and independent variable. This is the base of your SVR model. So here independent variable is age and the dependent variable is years of experience. Now, what we are going to do is we are going to train our SVR model to understand the correlation between the age and the year of experience of the person, and we'll be able to predict the year of experience based on their age. Now this is the data set, right? This is just a sample data set. You can see there are 15 records. This is just a sample data set to show you all how to implement it. Fine. You can use your own data set and you can work on it. Now, we'll go step by step. I'll show you all each step in detail. The very first step, what we'll be doing is we'll be going to import the libraries. So we are going to import NumPy for all the numerical functions. We're going to import matplotlib. This is for plotting the result. And then we'll be importing pandas, which will help you in your data analysis, right? We'll be reading the data using this pandas framework. So this is the very first step. Just import all the necessary libraries. Now, the second step, what we are doing is the importing the data set, right? We already have this sample data set now, and we are going to import this sample data set. Now, to use the import this, what we are going to do is we are going to use pandas, and pandas data frame will be using the function pd.readcsv. You can see here, this is the path where my dataset age.csv is stored. Now, creating a CSV file is very simple concept. Just open your Excel sheet, enter your data, and when you are saving it, select the option save as, and under save as select .csv comma separated file, and then you can save it. So Excel sheet, you just need to save it as comma separated file, that is CSV. Now, we have two variables as we already seen previously, the independent variable x, right? And what we are assigning to the x, the first column, the 0th index, right? That is the first index values we are assigning to x, and to the y, what we are assigning the predict, that is age, and y is nothing but the year of experience, that is the second column of our data set, right? We are reading it using this function. Fine. And when we are printing it, you can see when I print the head 5, that means topmost 5 sample records or the tuples it is going to display, right? You can see these are the 5 tuples index starting from 0 to 4. So it is displaying. Now the data is already read in the data set and we are printing top 5 data set. Now, if you use the corresponding ilog function to slice the data frame to assign these indexes to x and y. We already have used these ilog functions. Now age is taken as the independent variable and it is assigned to x. The dependent variable that is to be predicted is the last column and which is experience, and it is assigned to y, right? Now we will reshape the variable y to the column vector using the reshape -1, 1. I hope till here the concept is clear. Next. Third step, what we are doing is feature scaling. Right. Now, most of the data that are available usually are of varying ranges and magnitude, which makes building the model difficult. We'll be seeing this example when I'll talk about SVM. Thus, the range of the data needs to be normalized to a smaller range, which enables the model to be more accurate when training. So here the data is normalized between two small values near 0, right? So again, what we are using the sklearn pre-processing. Standard scalar is imported. Now we create two instances of scalar, one for x and one for y. Fine. Now the scalar is defined and then it is fit on the whole data set and then used to create a transformed version of the data set with each column standardized independently. You can see column x and column y, that is your independent variable and your dependent variable. Now the most The two most popular techniques for scaling numerical data prior to modeling are normalization and standardization. Now, what normalization does? Normalization scales each input variable separately to the range 0 to 1, which is the range for floating point values where we have the most precision. What standardization does? Standardization scales each input variable separated by subtracting the mean, that is called centering, and dividing by the standard deviation to shift the distribution to have a mean of 0 and a standard deviation of 1. Now, what the fit function is doing? For normalization, this means the training data will be used to estimate the minimum and maximum observable values, and this is done by calling our fit function. Now we apply this fit function to scale the training data. So this is done by calling the transform function, right? We say fit and then we say transform, fit transform, right? Now we reshape our data using the array reshape, that is -1 and 1 here. The data is reshaped here and here. Is it fine? So reshaping it converts it into a single feature. Now feature scaling is mostly performed internally in most of the common regression and classification models. Now support vector machine is not a commonly used class and hence the data is normalized to the limited range. So we already know support vector machine works only for the limited data and data needs to be in particular form. Okay. Now, what is the next step? Training the SVR model on the training set. So in building any machine learning model, we always need to split the data into our training set and the test set. The SVR model will be trained with the values of the training set and the predicted are tested and the predictions are tested on the test set. Suppose if you have 100 samples of the data, then 80 samples will be using for training the model and 20% of the samples will be using for testing the model, whether a model is properly trained or no. So again, you can just see here, the test size is 0.2, that means 20% of the data. No. The next thing what we have is training the support vector regression, that is SVR model on the training set. Now we are going to start the training. Here what we did the splitting of the data set into testing and training. And now using the training data set, we are going to train our SVR model. So in this, the function SVM is imported. You can just check it here. SVM is imported and is assigned to the variable regressor. Fine. The kernel here, what we are using now, you already know kernel. We already talked about it in the previous lecture. So here we are using radial basis function kernel. And RBF kernel is used to introduce a non-linearity to the SPR model. This is done because our data is non-linear. The regressor fit is used to fit the variable X train and Y train by reshaping the data accordingly. So X train is the value and Y train is the predicted value. Fine. Now the next step what we have is predicting the test set result. So here we have trained our data set and now we are going to predict the test set results. So we are going to check whether it's trained properly or no by passing the test data here. So in this step, we are going to predict the scores of the test set using the SVR model we have built. So again, here we are using regressor.predict function to predict the values for the X test and then we assign the predicted values to Y predict, right? So here predicted values are stored in the Y predict. And if you remember your previous lecture of SVR, we talked about the inversing, right? So here we are going to inverse the transform. So now we have two data set, that is Y test, that is real values, and Y predict, that is the predicted values. Fine. So what is real and what is predicted? Next, now what we have is comparing the test set with predicted values. So in this step, we shall display the values of Y test as real values and Y predict values as predicted values, right? That is actual and predicted. So predicted values for each X test against each other in a pandas data frame. Fine. So you can see here pandas data frame we have created as DF. What we are plotting here, the real values and the predicted values. I purposely taken the screenshot of the code so that you should understand if at all a warning appears when you're executing it, just ignore it. Fine. Now, this is what you can see your real values and the predicted values. Now we can see that there is a significant deviation of the predicted values with the real values of the test set. Yes or no? Just see what is the real value is 2. What it is predicting? It is predicting 9.4. Here the real value is 20, but it is predicting 23. Here the real value is 17, but here it is predicting 20.153. So what is this? This model is not perfect fit for the given data set. Is it fine? Now we can plot it and check it out. So before plotting, now these are the commands. In the last step, we should visualize the SVR model that was built using the given data. And what we're going to plot, we're going to plot the real values and the predicted values. Fine, these are the commands what we'll be using. So here you can see only 3 data points, and this is the curve what is drawn. Now why only 3 data points? And you see the difference of the data points. The real values are plotted in red and the predicted values are plotted in green. If the model is predicting it correctly, then they should appear in the same line, but there's lots of difference, right? So the model is not that properly suitable for the given data set, right? The same thing here, we have drawn it using a line. Is it fine? Now again the question may be why only 3 data points? Because what we are doing is, in case of SVR, we don't take the whole data set. What we take the points which are nearer to a hyperplane, which are very close to the hyperplane. So these are the 3 points which are close to the hyperplane, and these are the one which are used. I hope the concept is a bit clear. Okay. Now let us look at the code of screenshot of the code, how it looks when you type it in your Jupyter notebook. So I've just taken everything, the screenshots. Fine. Whenever the warning appears, the predicted values and how it is plotted. Fine. Now let us look at another example. So here what we are doing is we are going to predict the salary of a person based on his or her designation. So this is my data set. I have the designation and I have given a numeric value to the designation, that is grade 1 to 10, and this is the salary. So here we have one independent variable, that is grade, which is describing the designation, and one dependent variable, that is salary. So salary is depending on the grade. So what we are going to do, we are going to train our SVR model to understand the correlation between the grade and salary of the person, and should be able to predict the salary on their grade. Here I'm not going to explain the whole code again, because in the previous example we already had the details. So here I'm directly showing you all the code. So again the same thing, numpy for the numerical, fine. For plotting, this is for data analysis. What you're importing is the pandas. Here my data set is now salary1.csv. Again separating the data into X, that is independent variable, dependent variable, reading the data into X and Y vectors. Now again same thing, standardization and normalization or scaling, transferring the data set and storing it, importing our SVM. The kernel, again what we are using is the RBF, that is radial basis function. Now we are going to fit the model X comma Y, and we are going to make the prediction. The same thing again, inversing, right? Now when I'm plotting it, these are the plot statements or the commands what can be used. So x-axis label will be designation, though the grade values are there in the background, and y label will be the salary. Now remember what we are doing here, we are converting the values into float so that we get a proper result. So this is the screenshot what you can see of the code, and these are the result. Now you look at the way how it is trained. This model gives you the good result. Why? Because the green is nothing but the predicted value and red is the actual value, and the line is literally passing through the points. That means it could predict the values with a good accuracy as compared to our previous data set where there was lots of difference between the predicted and the actual value. Here it is giving good result. Is it fine? This is the data set. I hope the examples are clear, and what is expected is you can use your own research data and try to see whether the data set what you have for your research, is it possible to predict the values or to classify it using SVR model. Now these are the references what I used to prepare this lecture. Thank you. Stay home, stay safe.